So yeah, I'm Zamir. I'm a first year PhD student at the University of Exeter, and this talk is going to be on predictive processing and autism. So I was first kind of introduced to predictive processing in the first week of my master's year. We were doing a module on current issues in mind and cognition, and predictive processing was one of the things that came up, and I've kind of been fascinated by it ever since. And I think it's a really, really good framework for understanding not only kind of brain function, cognitive function, but also kind of lived experience, which we'll get to a bit. And then autism, I've kind of always been fascinated because I come from my trainings in kind of phenomenology and philosophy of mind. I've kind of always been interested in psychopathology and all its various forms. And autism just such a fascinating condition that it was really worthwhile to study. And I've since come to self-identify as autistic. So it's been a really nice kind of process of self-discovery, writing this thesis over the course of my master's and now continuing into the PhD. So let's just crack on. There's a couple of key questions that we're going to examine over the course of this talk. First one is, what are the problems with traditional accounts of autism? I'm sure I don't have to kind of hammer the point home to you that there's quite a few, especially with theory of mind account, things like this. So we'll kind of do a brief literature review of these traditional theories of autism and kind of draw out some trends and kind of set some criteria to what a satisfactory theory of autism might look like. And then I'm going to introduce predictive processing. This is, of course, the kind of foundation, the bedrock of my thesis, this framework in the theory of mind. And I'll introduce some of the core features, core components of predictive processing. And then we're going to look at if and how predictive processing can overcome the problem with traditional accounts of autism. I'm going to try and convince you that, yes, it can, and it can marry up quite nicely with the claims of the neurodiversity movement. So part one, this problems with traditional accounts of autism. Thanks for your facial expressions there. I'm glad the joke landed. My girlfriend did say potentially that the way I've worded this comes across as if I'm referring to the recent allegations against Sacha Baron Cohen. I'm referring to Simon Baron Cohen, but I'm sure I didn't need to explain that to you. So the central argument for this talk is going to be, one, just the observable fact that autism is a heterogeneous constellation of different traits. These traits are kind of distributed unevenly throughout the population. People can have some of the traits, but not others, or can experience different traits at different times. And there can also be different levels of severity or different levels of masking and presentation and so forth. So autism is a very diverse spectrum condition. That's why it's called the autism spectrum. But I want to argue in this first section that traditional accounts of autism fail to account for this diversity, and they do so in a couple of key ways. The first way is that they focus on one set of autistic traits, usually the social traits as the kind of the most obvious ones, at the expense of others. I think the main perpetrator of this is the theory of mind account, which we'll get to. And second is that they don't provide a specific enough proposal as to what's going on at the kind of cognitive and neural levels. They keep things very vague, and I think they suffer somewhat in their explanatory power. And there's a bonus failure here, which I've identified as well, which is they perpetuate a deficit narrative according to the kind of medical model of disability, which contradicts the claims of the neurodiversity movement, which says that autistic ways of being are kind of valid in their own right. So to make this argument, let's do a brief literature review. I'm going to cover three theories of autism. That's the theory of mind account, the weak central coherence account, and enhanced perceptual functioning account. So first of all, this is the theory of mind account with Baron Cohen, probably the most influential account in the autism literature. It's very popular and it's been developed in a variety of ways. But the main claim that the theory of mind account makes is that autism is characterized primarily by a deficit in theory of mind. What is theory of mind? Well, Baron Cohen et al. Define it as the ability to make inferences about what other people believe to be the case in a given situation, and which allows them to predict what they will do. The main evidence they use to support their claim comes from the Sally-Ann test. So I'm sure many of you will be familiar, but you've got kind of two dolls, Sally and Anne. Sally puts a marble in a basket and leaves the room. And while she's away, Anne switches the marble to the other basket. And when Sally comes back in, the experimenter will ask, where will Sally look for the marble? Of course, she'll look for the marble in the place where she left it originally. But they say 80% of the autistic participants in this study failed to kind of make this inference. And they want to use this to demonstrate that they have this impression that the knowledge that these autistic children have is the same that the knowledge that Sally would have. So they aren't able to make these inferences about the knowledge that Sally specifically has. So they conclude this paper by saying that our results strongly support the hypothesis that autistic children as a group fail to employ a theory of mind. We wish to explain this failure as an inability to represent mental states. As a result of this, the autistic subjects are unable to impute beliefs to others and are thus at a grave disadvantage when having to predict the behavior of other people. So it's quite a strong claim to make of this, diverse group of the autistic population as a whole. And there are a number of problems with this account, which are quite well entrenched in the literature, but we'll go through them anyway. First of which is, what is a theory of mind module, Simon? He kind of says that there's this, thing called a theory of mind module in the brain. It's this kind of discrete module, and that this module is impaired. But what seems to be going on here is that he's passing off this kind of ability to perform a task in the Sally-Ann test as a kind of discrete structure in the brain. But that doesn't seem to me to be very well evidenced, and it seems to be quite vague. It's not very specific. But also the main point is that how does this theory explain the non-social traits of autism? And of course it doesn't. It focuses specifically on the social traits of autism, but doesn't even attempt to say anything about, the kind of sensory processing differences, emotional processing differences, etc. And in a paper which we'll get to on the weak central coherence account by Frith and Happe, this is about as close to an academic diss as I think you can come. They say, by the stringent standard, that explanatory theories must give a full account of a disorder, not that well. So it's not very good. It only can explain kind of the social traits. And as part of this kind of bonus failure that I identified, the theory of mind account seems to perpetuate a kind of epistemic injustice against autistic people. Epistemic injustice being a concept raised by Miranda Fricker in a 2007 book, where people are specifically harmed in their capacity as a knower. So the classic example of this is with the concept of sexual harassment in the workplace. So before this was introduced as a concept, women who were the victims of sexual harassment in the workplace didn't really have the relevant hermeneutic resources to understand their situation. They didn't really have the tools required to understand what was going on. So this is one situation in which they're harmed specifically in their capacity as a knower. They're prevented from understanding their situation. This is a nice quote here from a paper by Legault et al., where they say, some social deficits associated with autism seem to be culturally maintained because the epistemic resources that allow autistic individuals to infer the mental states of neurotypicals are not equitably accessible. So there's this idea that the kind of neurotypicality is the dominant neurotype, designed a world by and for them, and that autistic people being forced to kind of inhabit this world don't have the relevant resources to kind of get on in that world. So there's a kind of, they're harmed in that they're not, the environment doesn't accommodate their autistic ways of being. Okay, so that's the theory of mind account. Let's move on next then to the weak central coherence account. I've chosen these three, by the way, because they're quite influential and popular, and they're also kind of in chronological communication with each other. So they all kind of try and respond to the previous accounts and build on them in various ways. So the weak central coherence account by Frith and Happe says that autism is characterized primarily by weak central coherence. What is weak central coherence? Well, they say that a characteristic of normal information processing appears to be the tendency to draw together diverse information to construct higher level meaning in context. So Frith, in her earlier book, kind of describes strong central coherence, the neurotypical way of processing things, as like a big central river, which draws together all these separate streams of information to represent, context and generalization to inform kind of judgments and information processing. And their main evidence for this is that, well, they point out quite rightly that 20% of the people in the theory of mind paper still pass the Sally-Ann test. So the theory of mind account doesn't explain all people with autism, because a significant subset of them, 20%, still managed to make these appropriate theory of mind inferences. And they also draw on kind of autistic superior performance on the embedded figures test. So this is a test whereby you've got a kind of complex drawing with all these different lines and shapes and everything, and the task is to find a specific shape that's made by the intersection of these lines. And autistic people are generally very good at this, so they say even better than the experimenters at the time. There's a mean kind of 21 out of 25 items that they identify correctly versus the neurotypical 15 or less. This seems to support their hypothesis that actually they're much more focused on specific details rather than being able to draw in all this contextual information, which would get in the way in the embedded figures test. And so they write, the hypothesis that people with autism show weak central coherence aims to explain both the glaring impairments and the outstanding skills of autism as resulting from a single characteristic of information processing. And this is kind of key, right? Because in the theory of mind account, they make this very kind of, at the same time, specific and vague allusion to this theory of mind module, which only explains, a very small subset of autistic traits, whereas here, weak central coherence is kind of characterized as a blanket top-down deficit. So it's necessarily kind of involves the whole system, it's system-wide. And so it has a much better chance of kind of explaining the whole range of autistic traits. But there are still lots of problems with this account. One is a lack of specificity. So even though it can accommodate maybe a broader range of autistic traits, it's not very specific. What exactly is central coherence in kind of cognitive and neural terms? They're not very clear on that. And what exactly is different in the case of autism at the kind of cognitive level? So they say in a later paper where they're kind of reviewing the work that's been done since they introduced the weak central coherence account, that a major limitation of the coherence account to date is the lack of specification of the mechanism at both the cognitive and neural levels that underlies detail-focused processing bias among people with ASD. So this is something that they recognize. It's not very specific and stuff that they've kind of developed in various ways. I won't talk about that here, but there is one strength to this account, however, is that it does recognize the positive attributes of autism. So like in the theory of mind account, for example, everything is discussed in terms of deficits and impairments. They're just, you can't help but get the impression that autistic people as a population are somehow worse. But in this account, they do at least recognize that autistic people can demonstrate superior performance in certain situations. But nevertheless, it's still cast within this overall deficit narrative of the medical model, where there's something to be fixed. Their central coherence is weak, it's impaired or deficient. So the final account I want to look at in this literature review is the enhanced perceptual functioning account. Maybe this one's a bit less popular. I certainly hadn't heard of it before I started writing my thesis and researching the autism literature. But in this account, autism is characterized primarily by enhanced perceptual functioning. So in this way, it's kind of the opposite of the weak central coherence account, whereas on that account, it's kind of deficient top-down. On the enhanced perceptual functioning, it's kind of enhanced bottom-up processes, as you were. So the main evidence for this is that, but I won't get into it here because they cite a lot of neurobiological detail. It's very, very specific and it's very well evidenced. But this claims to account for all of the traits covered by the weak central coherence account and more. So, for example, the enhanced perceptual functioning account can explain why autistic people tend to have intact or superior spatial processing, which seems to be quite a high-level thing that's not predicted by the weak central coherence account. So this seems to explain a wider range of autistic performance in certain situations. And so there's this bit of this tension here. So they write that we suggest that the bias toward low-level processing begins early in childhood and may be the consequence of a process of compensation for specific cognitive deficits by localized areas of the brain. So there's still this idea that maybe there's something that's deficient and that this enhanced perceptual function is a kind of compensatory exercise by the brain. You kind of, once it becomes entrenched that kind of lower level processes need to be relied on, these kind of perceptual processes, that's it kind of snowballs and it's relied on as more and more of a crutch, as it were, to compensate for these higher level deficits. But then they also write that within this model and concordant with empirical evidence, a deficit in global processing is not inevitable. So there's kind of a tension here, but I think it still belongs within the remit of these kind of deficit narrative theories. But I think, as we've seen over the course of the literature review, this one's definitely the best. It can explain the widest possible range of autistic traits. I've said all, but the widest possible range. And it does start with the assumption that autistic people are superior in certain perceptual situations. So it's not just a kind of incidental feature, it's built in. But the main problem with this account is that it can't accommodate for fluctuations between hyper and hyposensitivity within the same autistic individual. So the same autistic person might find something very overwhelming, or they might not be impacted by things at all. This is something that's been noted in the literature and is relatively common. So that's one problem with it, and it also still perpetuates a deficit narrative, like I've said. So that's the literature review of these three traditional accounts of autism, as I've called them. So what did we learn from this? What kind of criteria would it take for a satisfactory theory of autism? Well, for one, as we've learned from the theory of mind account, it needs to explain all autistic traits, not just the social ones. That's a pretty obvious point that I kind of can't believe that Baron Cohen missed. And there's also been a trend towards this kind of computational accounts of autism. So this is where you posit kind of cognitive mechanisms and the function of the brain as a kind of as an information processing machine. And we've generally seen a convergence of accounts where the main difference in autism seems to be some difference in how top-down and bottom-up information is computed in the brain. There seems to be some kind of imbalance that either top-down is weakened or bottom-up is enhanced. So this kind of hierarchical processing is also another key feature. And also, as we've learned from the weak central coherence account, it seems better to posit as few mechanisms as possible, but they nevertheless have the widest reaching effects. And so this is the kind of most parsimonious route to follow. We don't need to overcomplicate our theory with kind of all these different mechanisms. Like in the theory of mind account, you've got this theory of mind module that's somehow like there, but dormant in autistic people. You don't need to posit any of that stuff. Just posit a couple of mechanisms with the widest reaching effects. So those are the kind of criteria that we're looking at in a satisfactory account of autism. And I'm going to argue in the next section of this talk that predictive processing can actually meet these criteria. So what the hell is predictive processing? This is something that I've never heard of before. Like I said, the first week of my master's course, I still don't think it's very popular. But it's this kind of new and emerging framework in cognitive science, which states that the brain is organized into a multi-level bidirectional hierarchical structure where its functions prediction error minimization. What the hell does that mean? That's a lot of cognitive science mumbo jumbo. So in this section, I'm going to break down predictive processing by its core features. This and all that follows is only tended to be a kind of cursory overview, introduction to predictive processing, and we can kind of get more into the details of how it functions and some of the evidence for it in the question and answer section at the end, if you wish. So it helps, I think, when introducing predictive processing to think about the brain's perspective. So say, you're looking at a kind of organism in the wild, say there's a frog and there's like a particularly juicy fly that it wants to eat. You're tempted to think kind of, well, the brain sees there's a fly out there and it wants to, but you can't actually do that. From the perspective of the brain is trapped inside the skull. It has no direct access to the external world at all. So the brain can't perceive a fly per se. All it has access to are its sensory inputs, which, at base is just a particular pattern of energetic stimulation that constantly barrage its sensory receptors. So this is all the brain has access to. The other thing it can do is also issue motor commands and see the changes that result from kind of moving the body around. So this is the bedrock of predictive processing. We have to start with the brain's perspective. This is all that it has access to. How can it come to know what's going on in the world? So given that the brain needs to make adaptive responses to the environment, how does the brain figure out what's going on in the world? How does the brain come to realize that there's actually a fly out there and coordinate the body in such a way as to eat it? The answer given by predictive processing is that the brain infers the distal causes of its sensory inputs, distal meaning in the external world, by making predictions about what its sensory inputs would be if such and such were the case. So it tries to make predictions, in other words. So what is a prediction? A prediction is a particular hypothesis that the brain settles on about what's going on in the world, what the distal causes of its current sensory inputs are. And before the brain can make a prediction, it needs to consider and kind of consolidate two lines of evidence. First of which is the likelihood, which is how well the sensory input is explained by the brain's prediction. So say, for example, that you hear a kind of tick, 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 tick sound. This could be very well explained by a clock, for example. So the brain could settle on the prediction clock or watch or something like that. That explains the current sensory input quite well. And then the second line of evidence the brain needs to consider is the prior probability, which is how plausible the current prediction is. So importantly, this is kind of distinct from, independent of the current sensory evidence. So think, for example, with the same tick, tick, tick sound, it could be explained equally well by the hypothesis clock or the hypothesis time bomb. They both would explain the input quite well. However, the prior probability of there being the current sensory input being caused by a time bomb is quite low, right? They're not very statistically prevalent in the environment unless you're like a war zone or something. So given these two lines of evidence, the brain could settle on the hypothesis that a clock is the most likely distal cause of its current barrage of sensory input. And this is kind of along the lines of Bayesian reasoning. This is kind of Bayesian inferences. So this is predictive processing is also explained as the Bayesian brain hypothesis. This is how Bayesian inference is instantiated in the brain. And so this is how, using nothing more than its own states and the ability to make motor commands, the brain can make a prediction about what's going on without any direct access to it, which I think is pretty cool. But we can develop our story even more. So the second feature is prediction errors. So prediction errors, sorry, that should say, are the leftover bits of the stimulus that are not accounted for by the brain's prediction. And the best way to understand this, I think, is through an analogy as Andy Clark makes with kind of image compression. So when you want to kind of upload an image to the internet, you can't upload the whole information that contained within the image. That's massively wasteful. What you need to do is kind of compress the image and only send the relevant bits. So because each pixel in an image is a reliable predictor of the pixels around it, you can kind of take that as assumed. That's the bit that's predicted. The only bits you actually need to encode, the important bits, are the bits where the image diverges from what's expected. So when you get to a change of color or a line or a border or something like that, the bits where the prediction fails are the actually important newsworthy bits. And when you transpose this kind of same idea to the brain, the prediction errors, the bits that are left over from the brain's predictions, signal to the brain that it's made a mistake. It needs to update its predictions. So prediction errors are very important. Okay, so the next feature I want to introduce are the twin strategies of perceptual and active inference. So these are kind of two twin strategies that the brain has to minimize prediction error. So I'll go through perceptual inference first. So perceptual inference is where the brain updates its model to fit the world. So the brain uses this, as I've just described, the prediction error to learn from its mistakes, and it updates the model. So it makes better predictions in the future. And it seems like a kind of, from what I've introduced to predictive processing so far, it seems like quite a radical departure from traditional cognitive science. And it is in many ways, because the traditional picture we have is that kind of stuff happens in the world and it gets sent in through the eyes, then up to the brain, and it processes in more and more detail. Perceptual inference is it happens exactly the other way around. So the brain is actually making top-down predictions all the time. And the only stuff that actually gets sent upward to the brain is the bit where it's made a mistake, the bit that its prediction didn't account for. But this actually has quite a long history. So it's not an entirely new idea. And the kind of initial seeds of this idea was found in the writings of Hermann von Helmholtz. This is kind of polymath. And he writes that the operations of the brain that result in perception are in general not conscious, but rather unconscious. And their outcomes, they're like inferences insofar as we, from the observed effect on our senses, arrive at an idea of the cause of this effect. This is so even though we always, in fact, only have direct access to the events at the nerves. That is, we sense the effects, never the external objects. And this is very much still the case in predictive processing. This whole kind of process of perceptual inference that I've described is all unconscious. We never have we never have direct access to the external world. All we have access to are the kind of effects it causes on our sensory receptors. And then the other half of this kind of process to minimize prediction error is active inference. So this is where you update the world to fit the model. What does that mean? That sounds a bit funny. So recall the fact that I said the brain can also can issue motor commands, move the body, and hence move the sensory receptors in such a way that it causes a different pattern of energetic stimulation at the sensory receptors. Active inference suggests that the brain can move the body in such a way as to make its own predictions come true. So for example, if my brain predicts that I'm going to take a sip of my drink, it can either kind of just stay there passively and generate lots of prediction errors because I'm not doing that, or it can just simply reach out and take it out. And Jacob Harries says, he's one of the main guys in predictive processing, there's actually a bias towards active inference, this kind of active engagement with the environment to minimize prediction error. Since if you can imagine the brain's kind of static and it doesn't act, it will tend to increase prediction error over time, since the brain's model will kind of become more and more out of sync with what's going on in the world. So by acting on the world, the brain can always make sure that it has the most up-to-date model about what's going on. And this accords with like how we normally think of ourselves. We normally pick stuff up and look around it and walk around and check and look under things. And this makes good sense of why we're so active in the environment. But of course, this will always have to be interspersed with periods of perceptual inference as well. But notice that one kind of thing you can derive from this is that there's no clear separation between perception and action. So we normally have this idea traditionally that you perceive in order to process, and then the brain acts on the world. But that isn't the case in predictive processing. Perception and action are kind of two sides of the same perceptual coin, as it were. They're both strategies the brain uses to minimize prediction error all the time. And we're constantly fluidly going back and forth between the two. Okay, the third main feature is the kind of actual structure of the brain. So what the brain needs to do is to capture statistical regularities in the environment at multiple different spatial and temporal scales. So there's things that happen here and now, and there's things that happen a bit less frequently, and there's things that are very, very general. And the brain needs to kind of have a model of this whole different stack of spatial temporal scales. And what this means in practice is that the brain is organized into a kind of multi-level hierarchy. So at the lowest level of this hierarchy is the sensory receptors themselves. This is where the information from the world meets the sensory receptors. And as you ascend the hierarchy, you get towards very narrow spatial and temporal scales. And at the highest levels of the hierarchy, you have the most general, abstract ideas. And in order for the brain to make a specific kind of inference about what's going on in the world, you need the kind of coherence and harmony between the whole stack of neural cognitive levels. And so in this hierarchy, the predictions are sent in a top-down direction, and prediction errors are sent in a bottom-up direction. Obviously, that makes sense from the sensory receptors to the higher levels. And in the case that prediction error is generated, it's sent up to the relevant level where it starts to have an effect. And then the brain can kind of update its model in that way. So because we have this two-way flow of information, that's what we mean by bidirectional. Things can go up and things can go down. And these top-down signals, the predictions, constitute a generative model of the environment. What does that mean? It's generative because the brain kind of generates a virtual version of what it expects its incoming sensory data to be for itself, and it's a kind of model of these statistical regularities in the environment. And there's one more thing I want to introduce, which is the precision weighting of prediction errors. So in addition to kind of predicting what its incoming sensory data will be, the brain must also predict how precise its sensory input is likely to be. And what this determines is that how much influence the prediction error is allowed to have over the revision of the brain's current model. So for example, the brain will learn over time, over these multiple spatial and temporal scales, that the prediction error generated by sensory input will be more precise at day than at night, for example. It'll be even more precise on a clear day than a cloudy one. Or in the auditory domain, the sensory data is more likely to be precise in a quiet living room than a rock concert, for example. So the more precise the brain estimates its sensory input to be, the more influence it will have in updating the brain's predictions. And this is controlled, for those that are interested, in the gain on postsynaptic transmission in superficial pyramidal cells. That's how it's hypothesized to carry out, in addition to kind of various neurotransmitters and neuromodulators like dopamine, acetylcholine, that kind of thing. And this is actually quite important to bear in mind for my favorite predictive processing account of autism, which I'll come to in a bit. Okay, midway summary. I'm aware that was a lot of jargon and information, but this is basically all you need to understand, is that predictive processing is this kind of family of views. People take it and develop it in lots of different ways and have various different interpretations of it, but each have these core features. One, there's a kind of common currency of predictions and prediction errors. This is kind of the stock in trade of predictive processing. Also, that the brain is organized into a multi-level bidirectional hierarchy. There are the twin strategies to minimize prediction error of perceptual inference and active inference, and there's also precision weighting of prediction errors. And the overall function of the brain is prediction error minimization. So the brain wants to make its predictions as predictive of the world as possible. And so ideally, in an ideal world, its top-down predictions will be perfectly predictive of the world. There'll be no prediction error generated. But of course, that's not the case because the world is dynamic and shifting and changing all the time, and it's very complex. And so the brain wants to minimize prediction error in any way it can. Okay, that's the predictive processing section done. So let's look at how this relates to autism. And this is the kind of second half of my literature review, my thesis. What accounts are given of predictive processing and autism? So let's just return to our criteria needed for a satisfactory account. We said that a satisfactory account of autism needed to explain all traits, not just the social ones. It needs to be computationalist and have this kind of give explanations in terms of cognitive mechanisms and information processing, and it also needs to posit as few mechanisms as possible with the widest reaching effects. And so predictive processing, I think, has the potential to explain all autistic traits within this kind of computationalist framework, with fundamentally just a single computational principle of prediction error minimization, all of which comes down to that in the end. Let's have a look at a couple of predictive processing-based accounts of autism and see how they stack up compared to the traditional accounts. First one, which gained quite a bit of popularity, is the hypoparias account by Pellicano and Burr, which states that autism is primarily characterized by hypoparias. So what do they mean by this? They mean that the prior probability is kind of restricted or attenuated, so that autistic perception is much more influenced by the bottom-up sensory data rather than top-down predictions. You can cross-reference that with the weak central coherence account. It seems like it's saying roughly the same thing, except in this case, we have a very kind of specific cognitive proposal as to how this is cashed out. There's a quote from Pellicano and Burr: "People with autism see the world more accurately as it really is, as a consequence of being less biased by prior experiences." And this account makes a number of predictions that seem to be borne out in autistic people. The first prediction is that autistic people have more accurate perception. This seems to be validated based on the embedded figures test, and they also cite a slew of other things to suggest that that's the case. It also predicts that autistic people will experience more difficulties when priors would have helped to resolve ambiguities in a perceived scene, which the evidence also supports. They give this idea that, for example, people tend to have the very well-entrenched prior that light comes from above, as it generally tends to do. But because this carries less of an influence in autistic perception, they kind of say that, you know, the fact that lights come above and causes shadows and all these various things, it's less helpful in resolving where the light is coming from in autistic people. And they cite some studies to show that that's the case. They also make a prediction that autistic people are more likely to be overwhelmed by sensory input. This is obviously a common occurrence, autistic people being overwhelmed, but it's more subtle than this kind of suggestion that the weak central coherence and enhanced perceptual functioning accounts make, that it's a kind of blanket sensitivity, you know, because there's this wealth of information coming in, autistic people kind of get flooded by all this information. It's not that kind of overwhelming that they're talking about. They're talking about specifically being overwhelmed in response to the unexpected and unpredictable nature of external events. So because, as predictive processing states, the top-down connections kind of encode this generative model about the world, and because prior experiences have less of an influence in the predictions the brain makes, it's more likely that the current sensory input will be unpredicted and therefore generate more prediction error, which is what they mean by overwhelmed in this case. But there are still some problems with this account, primarily because they give this account in terms of Bayesian logic. The same predictions born out of the hyperprise account are also mathematical with the kind of complete inversion of this account. So with bottom-up enhancement rather than top-down attenuation. So think of the difference between the weak central coherence and enhanced perceptual functioning account. And there's evidence from two-tone images seems to suggest that actually the bottom-up enhancement accounts actually seem to be borne out. So these two-tone images are where you have kind of black and white splotches and you can't really make out what's going on. And then you see that it's actually just a high contrast image. And once you've seen the real image, it becomes very difficult to kind of unsee these black and white splotches in terms of what it's actually meant to represent. And in these studies where they compared neurotypical people to autistic people, they both performed the same. So it seems like top-down predictions are actually intact in autistic people, given certain situations. And to some extent, the idea of attenuated priors seems to play into this kind of deficit narrative, you know, somehow deficient priors. So here's another account. This is the one I actually favor. It's called the Hippia account by Van der Kruis et al. They say that autism is primarily characterized by a high and inflexible precision of prediction errors. So whereas on the hyperpriors account, the deficit or difference was at the cognitive level, this is at the metacognitive level. So remember, predictions are a kind of, precision weighting is a kind of prediction about prediction. It's predicting how precise the sensory input is going to be. So this is a kind of second order difference. And so Van der Kruis et al. Write that if errors are always deemed important, every new instance will be handled as an exception, different from previous experiences. In the long run, however, those affected by this dysfunction may succumb to a sort of learned helplessness, too much learning with no fruits. So the gist here is that this high precision affords to prediction errors, so this constant barrage of information is weighted very highly, interferes with the predictions flowing in the opposite direction, which, while still intact, nevertheless have reduced influence in the brain's predictions, what we consciously experience. And so the next few slides, I'm going to kind of examine or explore a couple of predictions this makes in various different domains, just to show how kind of wide-reaching this Hippier account is. So the domain of cognitive function, it can explain that autistic people demonstrate superior performance in attentional tasks. So attention is equated to be on the predictive processing account precision weighting. They're basically the same thing. And so if precision is kind of indiscriminately high, it can explain why autistic people perform better in certain attentional tasks. It can also explain why autistic people tend to have longer reaction times. This is reflected at the cognitive level by this kind of longer sampling time, because if prediction is kind of indiscriminately high and autistic brains kind of expect the world to be more precise than it really can be, and the person will spend longer time sampling the incoming sensory input, waiting to gather enough information sufficiently precise. And this seems to explain why autistic people may have longer reaction times in certain kind of decision and judgments. So in the domain of perceptual processing, the Hippier account is compatible with weak central coherence and enhanced perceptual functioning, but as we've said, it comes with a specific cognitive proposal. So now we can explain a bit more and go into a bit more detail. For example, why autistic people are more likely to struggle with face and speech perception. So if you think about kind of perception of faces, in neurotypical people, the predictions are at sufficient level of abstraction where they can take away the kind of unimportant noisy information, like the particular way light plays across the face and particular bits, everything. They'll be able to just generalize the category, this face belongs to this person. Whereas with autistic people, they're much more likely to be caught up in this kind of noisy, irrelevant data. And same thing with speech perception. As we've already said, autistic people are less likely to be influenced by context or prior experience. Could also say something about the increased rate of autistic savants. So they write that all known examples of savant skills, for instance, 3D drawings or musical play from memory, combine two factors: an exquisite discriminative sensory ability and an exceptional memory capacity. So the first, this exquisite discriminative sensory ability, is a core feature of the Hippier account. That's basically its foundation. And so in combination with the presence of exceptional memory, Hippier can also explain the existence of the kind of higher occurrence of savants in the autistic population. And of course, it can say stuff about social processing as well. So presumably, navigating the social world relies on kind of lots of complex, higher level information. It's not enough to look at the way facial expressions play out or gestures and everything. There's actually quite a lot of hidden meaning behind all this stuff, and there's no kind of easy way to map on one to the other. And so autistic people are more likely to struggle with integrating this higher level information in the presence of this noisy kind of dynamic social scene with lots of irrelevant and distracting information. And so they write that although the distinction between relevant and irrelevant information may be rather clear-cut in simple social stimuli, e.g. isolated, well-controlled, reused faces, that kind of thing, using ecologically valid stimuli implies more competition from distracting and irrelevant information, which is more likely to interfere with the higher level prediction. And I think this nicely explains, they don't really mention it in the paper, but the autistic people, I think this would be a common occurrence. It'll be interesting to see if you guys experience this as well. They're more likely to look at the mouth rather than eyes in conversation. And I suspect this has to do with using an additional kind of stream of sensory evidence to predict kind of what people are saying in speech perception. Same thing with using captions when you watch TV as well. It's another stream of evidence that allows you to kind of minimize prediction error and focus on what's important in the scene. And so this, I think, gives you the tools to extend the Hippier account in various ways. One of the ways I want to extend it is with emotional processing. There's a study that said around 50% of autistic people experience alexithymia, which is the kind of difficulty in categorizing, understanding, labeling emotions. And I suspect that the Hippier account can make sense of this, because if precision is indiscriminately high, processing will occur lower down in the hierarchy. This means that instances of emotion are less likely to travel up the hierarchy and be situated within an appropriate emotion category. meaning that autistic people will find it more difficult to label their emotions. So each emotion instance, it's not exactly the same. It has different features, different kind of color to it, or emotional valence. And I think that the brain's model is more likely to overfit to the data rather than sufficiently generalize and make these appropriate emotion categories. This is the bit I think is the most creative in what I want to do in my thesis, is that we can extend HIPIA to sort of talk about gender identity as well. So there's been a couple of reports to say that there's higher rates of transgender people and other gender non-conforming people in the autistic population than the neurotypical population. And I suspect that the predictive processing story of gender is that it's a high-level concept that's been kind of learned over time in our kind of cisgender binary norm. We're all enculturated in this kind of norm that encodes how people are likely to be treated in their interactions with others. So if I'm expecting to be treated as a kind of male, this will be a high-level concept that encodes for all of our dynamic social interactions. And if the HIPIA account is true, then I think that the higher rates of gender nonconformity in the autistic population can be explained by this lower level processing, interfering with the formation of high level concepts. We're kind of, less, the concept of gender will be less entrenched in autistic people, I suspect. But then I don't think that can explain transgender, the higher rates of transgender people very well. Why do they feel that they belong to the other gender than the one that they were assigned at birth? It seems to explain the gender nonconformity very well if you're not very, tied to one specific gender or the other. But then transgender people seem to provide a bit more of a problem case. So I was going to say, I need your help here. It'd be nice to see what you think in the discussion afterwards. Okay, have we done it? Have we succeeded in making a satisfactory account of autism based on the predictive processing framework? And I think we're almost there. I think HIPIA seems to me to be much better than traditional accounts. Satisfies all three of the criteria that we set out at the start, provides a powerful explanatory framework matched with a specific cognitive proposal. It retains the benefits and avoids the drawbacks of traditional accounts and can accommodate all their lines of evidence, but I think it's tied with this kind of explanatory framework and specific proposal. It kind of extends what they're able to say, as it were. And it also provides a better explanation of the heterogeneity of autistic traits and the existence of hypo and hypersensitivity within the same individual, because predictive processing is based on kind of all these various different factors like likelihood and precision and prior probability. I think it does a much better explanation of why autism presents itself in different people in different ways. But does it overcome the deficit narrative? Almost. I think it almost does. We're kind of there. So we've moved away from a narrative, if you notice, where autistic people are somehow deficient or impaired in a kind of like blanket sense that they're somehow worse off. And we've taken a significant step towards a view where autistic people merely have a different kind of metacognitive setup. And so they write in their paper, note, however, that predictive machinery in ASD is not deficient in our view. Predictions are still formed and prediction error is computed correctly. So given the setup of an autistic brain, the information processing plays out exactly the same as it would in neurotypical people. It's just that it has a different starting point. But I think the problem here is that we're still relying on the autistic individual themselves, particularly the autistic person's brain, which is wired up differently. So we're still looking to kind of the autistic person themselves as the problem, as it were. However, in the last section of the talk, and it won't be very much longer, I promise, I argue that predictive processing can be given a kind of externalist interpretation. We can move our focus away from the kind of individual person, the individual brain, and towards the many ways in which autistic people are related to their bodies and the environment and other people as well. So part 4, let's give this kind of one last pass and give it this externalist interpretation to overcome this deficit narrative. So I'm sure many of you will be familiar with the double empathy problem proposed by Damien Milton. The basic point is that it's not the case that autistic people fail to understand neurotypical norms. They're not just kind of wrong, but it's equally true that neurotypical people fail to understand autistic norms. It goes both ways. And so this double empathy problem forms. And Milton defines this as a kind of disjuncture and reciprocity between two differently disposed social actors, which becomes more marked the wider the disjuncture in dispositional perceptions of the life world. I put like it's easier for neurotypical people to describe autistic traits as deficits when the environment is set up so as to make autistic people deficient. The world is set up by and for neurotypical people. They are the ones that dictate the norms that our society is run by. And it's easy for them, in their council, as it were, to look down on all the autistic people and say you're deficient. But it's actually not true. It works both ways, as the double empathy problem points out. And so I think we can marry up predictive processing with Fourier cognition. I won't go into the exact details here. I can go a bit more into that in the discussion if you like. But Fourier cognition is a family of views which claim that the mind is one embodied in the organism. So it's not enough to just look at the brain. You have to look at the connections between the brain and the world. And kind of cognition is shaped and constrained by the body in various different ways. Two, that the brain, the organism is also embedded in the world in a particular material and socio-cultural context as the kind of background or field for everything that happens in cognition. Three, that cognition is kind of enacted in dynamic interaction between organism and world. So perception and action are kind of mutually supportive, and they kind of specify each other, as we mentioned in the kind of twin strategies of perceptual active inference. And fourth, that the mind is extended into external material artifacts, like classic example is Otto and his notebook. And I want to argue in my thesis that predictive processing provides the ideal kind of cognitive foundation to support a Fourier view of the mind. And if we can do this, then a predictive 4E approach can radically reframe what we mean by deficit. So it's not just the case that autistic people are somehow worse off, or they're deficient or impaired, but rather it's a relational concept. They're made to be deficient given the kind of environment that they're forced to inhabit. Autistic people are forced into environments that do not accommodate their style of information processing. So we've reframed the discussion from an individual brain or an individual autistic person to the whole matrix of connections between that person's brain, their body, and the wider environment, and other people as well. So predictive processing combined with Fourier cognition, I think, give me the tools to argue that we can't conceive of autistic people as wholesale deficient. They merely have a different cognitive setup, which allows for superior support performance in some situations and inferior performance in others. Sure, it doesn't circumscribe the fact that they're not in any way worse off, but this is the same with any other type of neurotype as well. They'll be better or worse depending on the situation. That's the main thing. And as Legault says, Fourier predictive models of cognition force us to reassess what cognitive deficit means by understanding all cognitive performances as embedded in environments or fields of affordances that shape and sustain. So it's very much relational conception. And this kind of brings to the fore the fact that I tried to put across, which is that neurotypicals as the dominant neurotype set up an environment that complements their style of processing and excludes all the others. And I think once we reframe the discussion into this kind of relational 4E account, it gives us the tools to combat the epistemic injustice that I highlighted in the theory of mind account. And I think there's a responsibility on behalf of the world to accommodate neurodiverse styles of processing. And that one way to combat the epistemic injustice inflicted on autistic people by the dominant neurotypical environment is that they can be allowed to enact, literally, bodily, in their dynamic interactions with the environment, a genuinely authentic autistic style of being. That is one way to combat the epistemic injustice. They're just allowed to be themselves and put themselves and inhabit environments that complement their style of processing. So, final summary, you'll be pleased to know this is the end. Let's pull the threads of this argument together. So in part one, we did a brief literature review of traditional accounts of autism, theory of mind, weak central coherence, and impact perceptual functioning. And I argue that they fail in two important ways. One, they either focus on one autistic trait at the expense of others, or two, they don't provide a specific enough cognitive proposal as to how this is cashed out in the brain. And in parts 2 to 3, I introduced the predictive processing framework, which posits that the brain predicts its sensory input in order to minimize prediction error. This is a unified vision of the brain where cognition, perception, and action all meet the criteria for a satisfactory account of autism, as we identified in part 1. And I think that the Hippier account in particular explains the heterogeneity of autistic traits, combines them with this powerful explanatory framework, and in combination with a specific cognitive mechanism. But we're still kind of focused on the individual brain. So in part 4, we reframe the discussion in 4E terms. So we can no longer hold on to this deficit narrative of the traditional accounts of autism, and to some extent the predictive processing accounts of autism as well. Instead, we're forced to view autistic cognition is one of a variety of neurotypes that's forced to process information in an environment designed by and for neurotypical people. And there's a responsibility on neurotypical people as the dominant neurotype to, accommodate neurodiverse styles of processing.